14 rectangular tiles with sides of length 3 and 4, and one square tile of length 1 to tile a square floor which is 13 by 13. Show that it's possible if we can cut the rectangles in half to make 2, 3, 4, 5 triangles for each one, but prove that it's impossible without cutting any tiles. Now, actually, I think it's a good way to go with this question is to do part B first. And I'm going to go through how the official solutions do it, and I'm also going to show how I did it because I feel like it gives some insight into part A as well. So here's our 13 by 13 grid. All right, this is such a nice way of doing it, which I need to get on board with, I think, but I always forget. So, okay, what we're going to do is just color some of the tiles. So if I color that one there, I know that I have to fit a 3 by 4 rectangle in it, but I then have to put another one, a different one, to color this square here. There's no way that my rectangle could cover both at the same time. And if I just keep going along by 4, then I'm definitely going to have 4 rectangles along the top. But then if I do the same going down, okay, and remember, I don't know how I'm going to orientate them, but I know there's going to have to be a different rectangle there, and then there, there, and there. I'm going to have 8 rectangles to cover these 8 dots. The same goes here, here, and here. So we need 16 tiles, or at least 16 tiles, I should say. And it could be the 1 by 1 or it could be the 3 by 4. So cover the blue dots. Since no tile can cover 2 dots, only have 15 tiles, so this is not possible. Okay, that is a lovely way to solve that question really quickly. I didn't think of that, to be honest. I thought about a slightly different approach. I thought, right, I've got my rectangles and I can put them along here. So let's just consider the base. Then I know that I've got 3 by 4. So to go along this base, I'm going to have X lots of the rectangles with the length of 4 along it, such as like here. So if X was 2, I'd have 2, you don't have to necessarily be next to each other, but 2 like this. And then 3Y for the number of rectangles in the kind of other orientation. And that is going to have to equal 13. Now I know we've got this 1 by 1 tile, but I can only use it in one place. So I can imagine it, well, if I did use it here, I can use exactly the same argument down this side. So I can ignore the 1 by 1. And I know that X and Y have to be whole numbers. So I could try out some values. I could maybe try, because there's no common factor, so I could try X as 1. So I'd get 4 plus 3Y is 13, so 3Y is 9, so Y is 3. And actually, that would work. X is 2, I'd get 8, so I'd get 3Y is 5. That wouldn't work. X is 3, I'd get 3Y is 1. And then if X was above, I'd get negative. So this is the only option. And I've got to do that on, well, every side, I guess you could say, except one where I might not have to. That's the only maybe flaw in my argument here. But let's say I use one that's length 4 and then 3 otherwise. So I could put it together. Let me go with the 1 to start with, like that. And it would be this. Now, I think you can argue that if you put the 1 in, like it's definitely going to leave a gap. There's no way, like if I put the 1 in here along there, there's no way it's actually going to work. So I probably write a little sentence about that, but I think we're okay. And then I'm going to have to carry on like this. Okay, you can see it is tiling. So we're just left with this blue square in the middle. But now I can make exactly the same argument. So how many tiles have I used? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, 3 by 4 tiles used. I have 2 left and 1, 1 by 1. But now I can make the same kind of argument. I've got to kind of fit one along here. So I'm going to have, this time it's going to be 4x, let me call it x dash. This is a different x plus 3y dash. That's got to equal 5. But this has no solutions. There's no way that I could fit a whole number of rectangles along here. Um, I can't sort of do that and then somehow fill this gap. It's not going to be possible. So that is a slightly different explanation for how we cannot tile it if we can't cut them in half. This is why doing part B first can actually be quite insightful because I'm going to pick things up with part A and try and now tile it where I'm allowed to cut them in half. Now, I don't have to cut them in half, or I can imagine if I have cut them in half, I can just put them together like this, no problem. Okay, so now I've got, instead of 2 4x3s, I've got 4 3, 4, 5 triangles. And 1, 1 by 1 square. It's a different ball game now. I didn't even need to necessarily do what we did here. I got to say, when I did this question, I was just trying to draw on the grid and somehow put triangles together. And yeah, I tried lots of things and it didn't work. It was only when I started thinking about part B, I thought this is actually going to be insightful for part A. Because now we've got our 5 by 5 square. So what if I just try and put the 5 length along the square? If I kind of turn it round, I'm gonna try and draw it like reasonably accurately here. So I know the area of this is 6, which means I can kind of try and estimate the height because then it's going to be, if the height is x, for example, no, not x, used x already, h, and I can see that a half times 5 times h is going to be 6. So h is going to be 12 over 5 or 2.2. Okay, so then I can kind of just roughly put it here. That could be maybe one of my triangles. And then I've got my right angle there. Let me label this angle in green and this angle in purple. But I know that these are going to add to 90 because I've got a right angle here, so the other two must add to 90. So then I've got my green angle there and my purple angle there. Now I'm going to draw another triangle on. I'm going to bring it in from here because I've got purple there and green here. They will form 90 degrees. That's my length of 3. And I can carry on in this fashion. So I've got another one here and then bring that together. And wow, suddenly we've got this 1 by 1 square in the middle. Might have been wondering where on earth that was going to come in, and it does in this final little bit. So this construction allows us to use all the tiles. We've cut the rectangles into 2 and then the square in the middle. So show that it's possible. It's possible using this approach. So if we're being extra careful, we might say, like this is 3, this is 1. You can see it's 4. You could even look at some of the angles. We've got 90 and 90. Okay, got the purple there, green, purple, and green. Okay, that is a really good question. Tough, I think, for sure. I think once you see the solution, like, there it is, but like figuring out that to do this is, I don't think is easy. But I think that is why it's question 6 ultimately. All I can say is, yeah, well done on any attempts you've made. Hopefully you can take a bit away from this, my solution. And yeah, keep practicing, keep enjoying your maths. Thank you.